These are some notes on the discussion board in Module 2 of Math 240, Applied Statistics. The topic in this module is application of normal probability distributions in making predictions. We can divide that up into two pieces. The first part is to learn how to calculate normal probabilities. This is a straight calculation technique skill. The second part on sampling is the beginning of applying the normal probability distribution to statistical problems. Sampling is when we have only part of the global data set. For example, we might be looking at every voter in the US. It's not practical to contact everyone, so we might talk to 1,000 in a sample. Or we might want to look at every possible summer day. It's not possible to do that over millions and billions of years, so we take summer days over a period of 50 years. Statistics involves a lot of sampling because almost always it's not possible to analyze every single situation. The discussion board this week is on the topic of sampling. Like last week, you have two options. The first option is to analyze several samples from the same weather database in option 1 of last week. Option 2 is for you to toss a coin multiple times and analyze the result of those samples. In both cases, it's more than recording what you get. In both cases, it's comparing to the statistical theory of what you should be getting. In option 1, you are to select some months from the large weather data set. Here are two ways that are unacceptable. You cannot just pick random months by hand. You can't say, let's pick December of 1937 and May of 1969 and December of 1971. You cannot go through and just pick dates by hand. That is not a random sample. Also, you can't go through each year and pick a month. So you can't say, well, let's start with 1939, we'll pick February. Let's go to 1940 and we'll pick May. Let's go to 1941 and we'll pick November. That is also not a way to choose a random sample. That's not a statistically valid way. We'll see in this course that there are some words in statistics, for this week the word random, that have very particular meanings in statistics. They are a lot more precise in statistics than they are in regular everyday English. When you say random in everyday English, a lot of times you just mean unpredictable. In statistics, random has a very specific mathematical meaning. It's much more than unpredictable. Here are two aspects that would make your post much better. The weather data set is much too large to analyze by hand. That's on purpose. We want you to use technology to do the analysis. Again, this is not the 1400s where everything was done by hand. You need to use technology. If you want to choose a random sample, you could use the randbetween function in Excel or the data sample option in StatCrunch. Those are two ways to choose a valid random sample out of a data set. Another good thing to do would be to relate your results to the theory. In this case, it's the central limit theorem, not the central limit them, as written in the discussion board, or the formula for standard error. As we go through this course, each week we will be relating data with theory. That's the whole purpose of statistics, is to be able to take data, numbers in particular, and make a mathematical conclusion rather than just say that, oh, it looks like this to me. Option 2 asks you to flip coins. So maybe this is more fun than option 1, but option 1 is more realistic if you're in an actual job. So option 2, flipping coins. Here are a couple things that you need to be careful of. When we do a statistical analysis, we need to distinguish between what's expected. For example, you might expect 50-50, and what actually happened. For example, you might get 6 heads and 4 tails. Those two are different. Of course, we're comparing them, comparing what you got with what you expected. Comparing what you have with what you expected is a common theme through every week in the rest of this course. Another thing that's not possible to do is to try your data set over again. Maybe you didn't like the results in the number of heads and number of tails. So maybe you decide to go and flip coins again. That's not permitted. In an official statistical analysis, that would be considered cheating. You cannot pick the data that you like. You have to analyze the data that comes to you. I see that kind of thing often in news articles. If you want to show that something is getting better, you go back in time and start with a very bad time period. If you want to show that things are getting worse, you go back in time and choose a very specific good time period. If you start with a desired conclusion and choose your data to support that conclusion, that's just plain being dishonest. Here are some good aspects that you could include in your post. A lot of statistics combines intuition with calculation. One part of this question asks you, is this close? Well, you can use some intuition or just some eyeballing. What would be excellent in statistics is to justify that with some statistical technique. For example, computing the standard deviation. That would combine a real-world conclusion with statistical justification. Part of this option includes looking at your classmates' data. So a very good post would include using your data combined with some classmates. Just like in option 1, when we study statistics, we're combining real-world data and problems with mathematical techniques. It would be excellent if you could take a look at your real-world coin flip data and combine it with the theory that we're studying this week, such as the central limit theorem or the formula for standard error. Here are some things that I look for and don't look for in comments. No matter how many times instructors say it, we always have students that just comment, "Great job," with no additional information. That's not acceptable. In this week, we asked you to provide some samples. It's very unlikely that you end up with exactly the same sample as a classmate. If you wanted to pick 100 months out of the last 40 years, it's really not likely that you pick the same 100 months as a classmate. In fact, you can do this over and over again, and it's highly unlikely that you'll have the same 100 months each time. Some questions this week for you to make a judgment, like accuracy is affected. You should justify your conclusions with something in statistics. It could be something with numbers, such as the standard deviation, or something with graphs, where you line up graphs with the same axes. To compare several graphs, you have to make sure that they're measured on the same scale. Here are two aspects that would make your comments much better. One of the topics this week is what happens when everybody in the class generates their own sample. What happens when you take those samples together? So instead of looking at your coin flips, what if you look at yours and Joe's and Marilyn's and Ben's and everybody else's? That's a new data set. This is a very important concept. You not just have numbers from your original data set, but you have numbers from the results from different people. Statistics combines numbers with applications. Just having numbers is not enough. Just having an eyeball conclusion for applications is not enough. You must have both. Here are some materials that we have for you on our YouTube channel. First of all, we have a bunch of calculation videos. These show you how to calculate normal probabilities either in StatCrunch or in Excel. You can use either one. We also have solutions for a couple of problems on the standard error, one for the mean, one for the proportion. In addition to guidance on the discussion board, option 1 is a little tricky because you need to do random sampling. That's a very useful technique to know. We have two videos, one that shows you how to do that in StatCrunch and one that shows you how to do that in Excel. You cannot do random sampling by hand.